I wanted to make the character hidden when he walked behind a building or tree and visible when moving in front of an object. It's called translucent sorting. However, I found out that Unreal Engine 5 does not have easy to use and out-of-the-box solution to configure this. So in this video I'll talk about translucent sorting policy in Unreal Engine 5, how it should work into the games, and why it doesn't work out of the box. Then I'll show you my solution for that. It's scalable, not heavy for performance, and made with blueprints. Few words about translucent sorting. Translucent sorting is a method of sorting the sprites on the screen. For example, if we sort by the y-axis, all sprites on the screen are given a certain priority depending on their world coordinates on the y-axis. This way, you can make the character sprite located lower on the y-axis have higher priority, so it will be overlaid on top of the building sprite. Conversely, when the character is above the building, its sprite will be hidden behind the building sprite. Unreal Engine 5 has a setting that should implement this functionality out of the box. It's located in the project settings, in translucent sort policy, select sort along axis, and in translucent sort axis enter -1, which means sorting along the y-axis. Also, for sorting to work, sprites must have translucent unlit sprite material. The nuance is that the sorting function in UE5 out of the box doesn't work optimally. It sorts relative to the center, not the pivot of the sprites. The character ends up behind the tree only when the center of the tree sprite intersects with the center of the character sprite along y-axis. This is inconvenient for any configuration. Will be perfect to sorting relative to pivot of the sprite. But with such condition of functionality, you will spend a lot of time to rework source images. My solution requires preparing a couple of blueprints, but then it will allow you to quickly and conveniently configure how a specific object is sorted on the screen. It's also inexpensive in terms of performance. The system will work as follows. We write a sorting component that calculates based on its position in the world on the y-axis. We insert this component into each actor that will participate in the sorting. For static objects such as building or vegetation, there will be additional logic with collisions. Sorting components are disabled and do not participate in calculations until a dynamic object crosses the collision. 10 times per second, objects are assigned a current priority depending on their position in the world along the y-axis. Objects will communicate through the interfaces. And this gives us needed behavior. Let's start by creating an actor that can be a parent for all environment elements. It will store the general logic necessary for sorting. In it, we add a sprite that will participate in sorting. We can also add a flipbook if the object is animated. Let's move to creating a sorting component. In it, we create the set content to sorting function. Then add sprite variable with sprite paper component type. And flipbook variable with flipbook paper component type. In the function, we will write the sprite or flipbook of the environment element that will be sorted. Then we add created sorting component to all actors which will participate in sorting. In our case, this is the character and the previously created environment actor. At event begin play, we will connect the set component to sorting function and repeat it in every actor. We will connect the object's sprite component. In the case of the character, this is our body, and in the environment actor, that's just empty sprite which we created previously. This will tell the component which actor sprite should be sorted. Let's go back to the component and create the function setPriority that will assign sorting priority to the selected content. Let's add a setTranslucent sort priority node and connect the sprite variable. Value of y of the actor location will be used as the priority value in this node. But we need to update the sorting priority values. To do this, we will create two events, start sorting process and stop sorting process, and timer. At the timer output, we will connect previously created setPriority function. This function should also be triggered once at the beginning of the component's action. This will save us from a number of bugs. Also connect event and play. Stop sorting process event should stop the timer. We will also pass the y-axis position of the actor that owns the component to the setPriority function. Also add validation to prevent any bugs. That's all for the component. Let's move on with the environment actor. We need to add logic of activating and deactivating the sorting component. To do this, we will add a square collision component and name it sorting area. For now, I will make it visible in the game for convenience of configuration. Let's take two events, on-component begin overlap and on-component end overlap for our sorting area. To test the collision, let's add print string nodes for each of the events. When the collision boundary is crossed, the word catch will be displayed. When leaving the sorting area boundary, a return will be displayed. For test, I created the child class tree of parent class environment because parent class shouldn't have any resources like sprites or flipbooks, but only general logic. I'm setting sprite of tree and also configuring size of sorting area. Let's check if the collision is working correctly. The words appear, which means everything is good. As I mentioned earlier, component is initially in sleep mode and the logic is not executed, so as not to use resources. When a character crosses the boundary of an environment, both sorting components must be activated in the tree and in the character. To do that, let's call the start sorting process function of environment in the environment parent class, then cast to the character blueprint and call the same function of character. Don't forget to disable the components when exiting the sorting area. Sorting now works related to the pivots of objects. I will highlight the pivots with arrows for visual clarify during testing. Let's test it. As you see, sorting is working. The character hides behind the tree sprite when its pivot is higher than the tree's pivot. To make this look better, we need to move the tree's pivot lower towards the base of its sprite. This can be done directly by simply moving the sprite component in the actor on the scene. Or you can do the same thing in the actor's blueprint. We could stop there because overall everything works. However, the logic can be improved. Firstly, the logic currently only works with the main character, because we cast specially for him, but mobs and enemies can also bypass objects, and they will not hide correctly behind the objects. Secondly, you may encounter the following bug. Suppose there are two trees standing next to each other, and their certain activation zones are related. When I enter the area of the first tree, its sorting is activated, and I can correctly hide behind it. Then I cross the boundary of the second tree, and everything is fine with it too. But when I exit first area, while still in the second area, the sorting on the character is suspended. To fix this bug, we will make very simple token logic. When entering the area, each of the actors involved with the sorting component is assigned one token, and when leaving the zone, the token is lost. Thus, sorting on the character will end not when you leave at least one zone, but when the number of tokens on the character is equal to 0. Create the update sort tokens function and tokens amount variable of type integer. We add the input value increase of type bool, then branch node. If the value of the increase variable is true, we increase the number of tokens by 1. If the value of increase variable is false, we subtract 1 token. In this case, the token value cannot be less than node 0, so we add an additional max node with value 0. After that, another branch with check. If the number of tokens is greater than 0, we start or restart the sorting, or otherwise we stop it. In the environment, actor connects the token update function. Thus, when activating and deactivating the sorting area, we run the sorting logic on the current environment actor, but we still need to run the logic on the character. The best option to do that is Blueprint interface, because you can refer to any character or dynamic object that has this interface. Add the update sort tokens event with input parameter increase of type bool. Add this interface to the character. Link interface with the update sort tokens of sorting component. Return to the environment actor and message update sort tokens event of interface from overlapped actor. And everything works correctly. That's all. Now, if you want to create an object behind which a character or mob should naturally hide, just create a child of the parent blueprint BP environment 0, where you can add the logic necessary for your object, as well as if your new object is just a decoration and does not require its own logic, you can simply place the parent blueprint on the stage, insert the necessary sprite, and adjust the size of the sorting area.